podcast time.
Guten Morgen, everybody. Good morning, everybody. We are back to our podcast session. Myself, Michael, and Dr. Ram Hashmonai here.
Hello, Michael.
Good morning.
Good morning. Good afternoon.
Yeah, it's already afternoon.
Somewhere it's afternoon.
Yeah. So today we want to speak about some more of a technical part of OGI and how it really works. What are the the products, and compare the solutions, different type of solutions to the detection performance. So from your background, and we all already know that you're a well experienced scientist in that thing. So how does the detection sensitivity of an OGI camera, in comparing to the sniffing technology or the Matter 21 technologies, how it really reflected? Like what is the pros and cons?
Okay, OGI is a different animal. It's not the same type of technology. It's visualized. It's not actually measuring concentration. So it has an advantage to see where the emission is coming from. It's very sensitive, but its sensitivity really depends on how we sight, what is the angle we look at the camera, what are the environmental conditions. There is wind. It's very sensitive to environmental condition to be sensitive enough. So with OGI technology, in laboratory conditions, it's much more sensitive than even a leak, a sniffer, because a sniffer, you need to get very close to the leak in order to measure it. Actually, the concentration is very sensitive, but if you are not
On the spot.
you are not on the spot, you will not measure it. So I think OGI has the potential to find leaks faster and more smaller leaks than has the potential to find, but the user is very important, how you use the camera. But it's hard to compare them as far as sensitivity, because OGI is not, we are talking about performance envelope in different conditions of temperature difference between the background and the air, or wind speed, distances. All of these are variables that affect sensitivity of OGI, where a point monitor like the sniffer actually has a defined sensitivity at a point. So if you are at the leak source, it has a sensitivity of whatever, 1 ppm. So you'll measure everything that is above 1 ppm, you'll measure it. So it's hard to compare. Some leaks, you better measure it with a sniffer, but always visualizing better with the OGI. That's the main advantage of the OGI technology.
So basically, they're not competing with each other. It's just more of a complementing each other in this side.
Nowadays, the whole leak detection is driven by leak rate, not by concentration around the leak. Because we didn't have technology historically, we didn't have a technology that can measure the leak rate or define sensitivity at leak rate thresholds. We use the concentration, but you can measure with a sniffer 5,000 ppm or 10,000 ppm, and it could be very small leak. Depends on the wind speed, depends on many other factors around the leak, how close you are, because most of the time the leak concentration, if you get really close, it's beyond the measurement capability of the sniffer. It's maybe 20,000, 30,000 ppm, you cannot measure any more than that. And 100% of methane that coming out of a leak is 1,000,000 ppm.
Right.
So,
I'm just concluding what you said. So basically, the sniffers are also a subject to environmental impact in terms of the sensitivity.
No, it's how you measure it. It's not environmental impact. It's more like where you measure and yeah, it has some wind speed, but it doesn't give you an indication of the size of the leak. You
Right.
know, what is the intensity of the leak? What is the leak rate? And that's what important. You want to fix or repair any leak that is above a certain amount of mass per unit time going out to the atmosphere. You don't want to measure concentration of 100,000 ppm can mean a wide range of leak rates.
Right.
So you don't know if it's big, small. It really depends so many. So it doesn't measure a leak rate, the old technology, but that's what they have before. Now we have an opportunity to define it as a leak rate sensitivity.
Correct.
Either.
So basically, well, like, the customers are normally asking, like, okay, so you have this X grams per hour leak or X units per unit of time leak, but what about the concentrations? Eventually, they're still stuck in that not
That,
previous, but
so you need to tell the customer also the regulation, European and US regulation move to leak rate thresholds. You
so
know, 17 gram per hour in Europe for methane, 19 gram per hour in the US, and that's how we define the leak that this technology needs to measure. So
they're
to
all talking
detect.
about mass flow.
But in the old days, when you couldn't measure, you cannot define it as a leak rate because of the limitation of the technology. They got used to ppm. We can see 5,000 ppm. Why should we care? Sometimes 5,000 ppm is well below the 17 gram per hour, and sometimes
Correct.
it's well above. We don't. It's
So it
not
doesn't
in
really make
indica.
any.
It's not proportional to the leak rate, and people need to understand it and use. You answered these people. This is how we did it in the old times. Now regulation and scientists agree that we should move to a leak rate, mass flow leak rate,
Mhm.
and not ppm. But old regulation that didn't change still defined in ppm. So the answer, if we is, you can measure 500 ppm. The answer, yes,
Okay.
you can, because we are sensitive
Right.
as we are the OGI technology, the cooled OGI technology in the midwave IR is sensitive and can find many more leaks than the old ways of the sniffer.
Sure. So again, previously, just question popping up here on the online. Um, the gentleman here is asking, whenever how big is the impact of the human being while you're doing the inspection? What is the big, like? Is it the limitations of the technology normally impacting the data, or it's the human factor here, which is
Oh, there are papers by scientists that examine the human factor, and uh, you need to be well trained how to use the OGI. It's to operate it. It's very easy. You
right?
open and in 10 minutes you know how to operate it. But how to make sure that you're not missing leaks, you need to have experience. And the new regulation, the Appendix K new regulation, which is the method for OGI practices,
Mm-hmm.
requires a lot of hours of training, and it takes you a long time until you be a senior, well, what they call it,
See,
inspector, OGI inspector. It takes a long time, like 1,400 hours. I don't remember the
oh,
number of hours.
that's a
So
lot.
it's a lot of hours of experience before you can become. And the reason is the human factor is very important because the human decide uh, if there is a leak. He looks at the images and he looks outside the camera. If he doesn't see anything outside leaking, he doesn't see steams or dust or anything coming out of the pipe, but he look at the camera and see some activity, he knows it's a leak.
Mm-hmm.
But there are all kind of effects, and sometimes you need to change the angle, get closer, change the background temperature because we didn't go into the science of OGI technology, but the temperature difference is the most critical.
I see.
Uh, uh, they call it the delta T. The temperature difference between the background and the air
Mm-hmm.
is a key variable. If it's big, the camera is far more sensitive. If you have a very small temperature difference, the camera is much less sensitive to finding the leak. So the user can change the angle, choose the background, look from a different perspective, and improve and optimize the detection capability of that scene.
I see. So, for instance, if we're taking out the human factor, so and we're talking about a fixed OGI camera, fixed sensor, like will that be a good improvement, or it's still gonna have those the same limitations?
No, this is already a different, totally a different story. You know, you take the we can talk about the fixed camera when the human is not in the loop
Right.
and cannot see. The camera or the algorithm need to decide if there is a leak or not a leak. So there are different ways. Some of people use AI for that. They use all kind of algorithm to improve the reliability of the gas detection and quantification. But this is a different story because but the environmental conditions are still key. So if you have a sun angle and you don't have a background, or time of the days that the atmosphere you have low visibility, all kind of environmental condition will affect your sensitivity. That's why on the fixed installation here in Obgal, we like to use a system that has a camera to visualize the leaks and sometimes to quantify, but we're using other source of information from operation, from sensors on site to close the loop on the detection if it's really an emission event or is it just a false positive or what kind of false alert.
Well, for instance, I'm just giving an example. If you have like a dust cloud traveling through the facility, when so could it also like
If you don't, if you are a human
yeah.
looking with a portable camera, you know, you see the dust, you know what you see in the dust. We have ways by using other sources of information, a day camera like an RGB camera or other sensors to triangulate the information or to get to a closure to make the decision if it's and we have some filters and we're using AI. There is a lot of ways to make sure once you suspect once the algorithm suspect there is a leak,
Mhm.
you can color it. You do a lot of checks before you release an alert and make sure from the sensors, from operational information, whatever is exists to make sure you crisscross everything and make sure that it's a positive alert.
Okay, but you still require human intervention in that process, or it can be
No, no, no.
fully automated.
It's not perfect yet. None of these OGI, but it's going there with that it will be. And sometimes in very low probability, you will have a false alert, but most of the time it will be a very reliable system that you don't need a human. You need the human to fix the problem, but you don't need it to get the alert. You'll get the alert. Once you get an alert, the OGI has a big role in what we call root cause analysis to find you can get control on the fixed camera, you can use mobile cameras, you can go to the areas of the alert, and you can really pinpoint the source with
Correct.
other, but only after the system send you the alert, the human become, or the robots will become very important.
I see. So I'm just, you said that multiple technologies can be involved, and saying that like the OGIs, we already spoke about the handheld device, and we've, been talking about the fixed installation devices. Uh, Again, fixed OGI cameras. But what about flying camera? Will that be in that perspective any supportive tool? Like,
Yeah,
adding it as a layer.
in different episode I started with the helicopter story
Correct.
that it started from the air, but now we have drones, and the drone could be like the robot that go and do the root cause analysis that I just mentioned after the Alex of the fixed system. The fixed system is like a fence line monitoring on site fixed system that always uh, look at the site, measure the site, and make a decision when you have an event. You have an emission event that you need to attend. You need to find the root of this event and you need to fix it or mitigate the situation. But you can use the drone in this
Right.
scenario. You can send a drone to this area instead of people. You
Correct.
can send a dog robot. You can do in the future. You can do a lot of things without the human. But right now we're going to use the person with a portable OGI camera, and he will find it and fix it. The drone can be also part of routine checks from above, but this is something that the new regulation at EPA give an opportunity to uh, develop and propose methodologies for screening.
Hmm.
Screening, instead of doing LDAR, having once in 2 weeks to do like a screening, emission screening technology. And the EPA already approved several methodologies, and they include sometimes a flying laser or a flying OGI,
Okay.
and they use it for routine checks, but it's periodic screening, not continuous like fence line monitoring.
So basically, the like integration of all flying platform, drones, flying platform, fixed and handheld, and all of that. Does it? I mean, it has to be any like a command room or a data center where it's all, where all of the data collected, right? So that could be manipulated from one command center, and that should really create a coverage. Let's say I would call it a dome, but that's supposed to be some.
Yeah, there is like a trade-off between the spatial coverage of your system and the temporal.
Mhm.
You can have a continuous cover, you can have everything working all the time, 24/7, and it's very not. Even though you never miss a leak this way, and also the people work 20 in shifts and 24/7. This is the golden standard, but you need to have subsets of this, very wise and design
Correct.
to integrate what you need to have 90% of these capabilities, but have systems, reduce amount of monitors and cameras, and do most of the work. So this is where we at Topgal changed the approach, going from selling camera for fixed camera for 24/7. We are actually custom design and tailor a solution that could be a combination of sensors, cameras, portable
Right.
cameras, drones, whatever the client needs to solve their problem. Not one size system fit all scenarios. We actually look at the problem, we listen to the clients, and we're trying to tailor a solution for them, not selling them cameras, selling a solution that combine a lot of technologies together.
Right. So that's what basically what I'm, kind of thinking, because, you cannot compare each and every site to be, you cannot expect each and every site to be the same, right? So there's different environmental aspect, there's different equipment aspect, there's different, scenarios of use, different compounds, and so on.
Different regulatory pressures.
Correct.
That's the main thing.
So what I'm saying, like if you're taking the upstream facility for actually production, and then you would just randomly take some small refining process, will the application be the same for those two, or it
No,
will?
no, exactly what I said before. It could be different cameras. We have different ranges. We have different compounds. We have different, and some of the places need data to cover every day, every night. Or some places they want us to sample. So it really depends. What is the problem? I can give an example. Some facility has a routine docking station that have barges coming in and
Correct.
down, or
So the terminal.
yeah, terminal, and you need the camera to work only at that time, because when they approach, they may emit toxic gases, and if they are measuring these toxic gases on their fence line monitors, it's considered their emissions when it's coming from the outside.
vessel, right?
So they want to know beforehand, before it's approached to the dock, If it's so, this is a kind. You listen to the problem and you're trying to provide a cost-effective solution to them that will be cover enough of the space that you need to monitor, and over time you need to define the time resolution. But it always will drive different type of cameras. If it's only methane in small ranges, you may use uncooled cameras. If you need long ranges and it include VOCs, you need cooled cameras.
Correct.
We have also the flexibility to change inside the MWIR, the mid-wave IR cameras, to change the spectrum for long range to short range, benzene and methane, and depends what are the compounds of interest. And we will always combine sensors, suitable sensors, to get better idea on speciation, because let me remind you, the OGI is not a full solution because it cannot speciate. You need some more information about this speciation in order to have a complete solution that will satisfy the client.
Correct. So, just summarizing up and kind of wrapping this whole podcast up. I was thinking. So basically, Opcal today can provide variety of solutions, can provide a variety of technologies or combinations of different technologies to eventually set up the system that way that it can be used for variety of applications, and then however the thing is that eventually the whole solution will provide a holistic answer to this demand of the customer, and this kind of approach on my end, so it looks very way more well suits well better for the customer than just a standard random like a security camera stuck out there. Well, okay, great. So I think have all of my questions answered here, but you can all approach us, Dr. Ram Khashmani and myself, for more details if you think of getting this kind of solution and implemented that in your facility. But that was it. So thank you very much.